Today we'll be investigating the different measures of center as we talk about some of the attributes of our graph. Remember, we talked earlier about the four things in describing graphical displays: center, shape, spread, unusual occurrences, and we're going to focus today on measures of center. Now, there's three types of measures of center. So when discussing the center of a distribution, we want to focus on one of the three measures here. We have mean, we have median, and we also have mode. Now, most of us are fairly familiar with the definitions of each one of these. We've used these in calculations before, and again, we're going to focus our studies on measure of center here and talk about each one of these calculations and the importance in their use when describing the features of our distribution, in particular here, center. Now, before we talk about each one of these three measures, let's define some important things here to help us in understanding what we're going to use for statistical measures. Let's begin with the definition of parameter. Now, a parameter basically is a fixed value obtained from the entire population. And typically, this value is unknown. When we talk about parameters in the study of statistics, we're talking about values that actually come from an entire population. Oftentimes we want to know the attributes or the values of a parameter, and unfortunately, because our populations are so large and we're unable to do a complete census on the population, we're going to have to estimate parameters. And in particular, when we talk about center, we're going to take a look at the different values of parameters from a population, and in particular we're going to talk about the mean and what its value is as a parameter. Now, because our populations are so large, we typically use statistics to estimate parameter values. A statistic is a value that is calculated from a representative sample of the population. We base, in this case, the center of our sample distribution. If our sample's chosen properly and we're fairly good with how it was selected, we typically take the center of the sample distribution and we estimate that to be the center of the population itself, which would be a parameter value. So the statistic we use to calculate based on the sample can be used as an estimate of the true parameter value. Now let's begin talking about the median. The median basically is the 50th percentile. The median is the middle of our data. No matter what the shape of our distribution, whether it's symmetrical, whether it's skewed, whether it's uniform, whether it's multimodal, bimodal, no matter what the shape of the distribution, the median is always the 50th percentile. So the location of the median is basically going to split our graph into two equal areas on the left and on the right. Now, to calculate the median, the first thing we always want to do is we want to place our data in ascending order. Once the data has been placed in ascending order, we're going to take a look at the number of observations that we have, either from our sample data or if we're doing the median parameter value of a true population, we want to find out if the number of data points is odd or if it's even. If the number of data points that we have in our data set is odd, we simply take the middle single value to calculate the median. If the number of data points in our data set is even, we take the average of the middle two numbers. So once again, to calculate the median, if we have an odd number of observations, we're just going to take the middle single value. And if we have an even number of observations, once we put our data in ascending order, we're going to take the average of the two middle numbers. Now, the mean is basically an arithmetic average. The mean is another common measure of center. The mean of a distribution can be found by taking the average of the data. It's basically a numerical average of our data values. To calculate the mean, we're going to sum up all of the observations in our data set and divide by the total. So the mean is basically just an arithmetic average. Now in our formula here, we represent the mean with x bar. Now x bar represents the mean that's actually taken from sample data. Now, if we do know all the values of our population, we do calculate the mean in the same way, but we don't call the mean x bar. We actually call the mean mu. Notice that we use the Greek symbols when we're representing parameter values. So to calculate the mean of a population, once again, we sum up the observations and we divide by the total number of observations within the population. And the mean